And I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. And thanks again for joining us for today's presentation, MSDN webcast, a lap around HTML5, HTML5 graphics. And so without any further delay, I'm going to turn the floor over to today's first presenter, Lindsay Lindstrom.
Great, thank you, Tracy. Welcome everyone to the third webcast in our four-part series on HTML5. In this webcast, we'll talk a bit more about some of the graphics elements that we covered in the first session, specifically SVG, Scalable Vector Graphics, and Canvas. With me, I also have Tara Walker, who will be talking also in this webcast, more specifically around HTML5 Canvas. And I just wanted to point out that our email addresses and our blog addresses are on the screen. And again, if you print these PDFs of these slides, you will have those. And you can go to Tara's blog and my blog to see the resources from today's session. And as well, contact us via email or Twitter should you have any questions that we can help answer. Just to recap, this is a slide denoting the different aspects of HTML5. Now, when you refer to HTML5, you can be referring to the script, the markup language, markup language itself, but also to the world of HTML5, and this it says and friends, including the markup, which is denoted by that little blue sliver on the left, and CSS, cascading style sheets, JavaScript, as denoted by ECMAScript and ECMA, web apps, so APIs for targeting all things like web storage and server-side things and SQL and all kinds of stuff, just some APIs that you can use, as well as SVG, which is something that we're going to talk about today. So these orange sections are different working groups who are working on defining the different specifications of HTML5 and friends. One thing I like to say is kind of the sweet spot of your web application not only uses HTML and HTML5, but JavaScript and CSS to create a very good-looking, useful, and compelling website for your users. Now, graphics does have something to do with this, and so when we talk about SVG and Canvas today, you will be working, of course, within HTML5, and you can use CSS and JavaScript to manipulate your graphics as well. So CSS, and I know we went over this last time, so I'm not going to go through it. If you want to learn more, view the on-demand version of our part 2 of our series. But the reason I'm talking about styling with CSS is with Scalable Vector Graphics, you will be able to use CSS to style your elements. So thinking of all the new things in CSS3 as well as previous versions of CSS, you can do some pretty fun things with your graphics. The other part that has to do with graphics is being able to use hardware acceleration in IE9 and above to make sure that your users are having a great experience. So this allows us to not just use the GPU, but also the CPU to render the graphics on our site. So it's just a quick slide. We talk about it more, again, in part 2 of this series. But now that GPUs are commonplace in most modern machines, and also modern machines have multiple cores, we can use something like IE9 and above, IE10 in its preview state right now, which also uses hardware acceleration, to really harness the power of our machines and our sites. So one site that you want to take a look at, and we'll be referring to it quite often over this presentation, is ietestdrive.com. It's also a link in the resources of this slide deck. And if you go to ietestdrive.com, you can take a look at some of the scalar SVG usages and Canvas examples, and how IE9 uses Canvas and SVG to create really compelling demos. So take a look at that site. We'll show you a little bit of it as we go along. So to get started, I'm going to talk a bit about SVGs. So Scalable Vector Graphics has been around for a while. It's not a new thing. It's not like something brand new with HTML5, but it's basically an XML-based language that allows you to describe your graphics objects and scenes. The elements, your SVG elements can fire events. You can script them with JavaScript, which is really compelling. There are built-in primitives like circles and rectangles, and you can even display text. Of course, they're vector-based, which allows us to, see them rendered and not pixelated, depending whatever resolution that I'm using. And right now, we're currently in version 1.1, though 2 is currently under development. And there's kind of a SVG 1.1 second edition, which is currently in last call from the SVG working group in the W3C. But again, it's not part of HTML5, but it's definitely integrated very well. Let's see, my next slide. Oops. Wrong window. Okay. So I mentioned this very briefly, but SVG is basically declarative XML. So if you can kind of think about it like HTML in terms of its layout, but XML allows us to be able to easily use accessibility, like screen readers, as well as SEO to understand not just the content of our page in terms of text and semantics, but also the graphics of our page that we can describe easily with XML. Since it's not a new technology, it's been around since the early 2000s, there are lots of tools that can manipulate and create SVGs and such. So with IE 8 and below, there was a plugin available that you could install to read SVGs on a site, but with IE 9 and above and other browsers and above, you can understand SVG it's built into the browser and therefore can interact with HTML5 and such. There's a lot of different tools. I'll point out a few to create SVGs, as well as even if you're using something like Visio, you can export an SVG file. The primitive shapes I mentioned, like rectangles and circles, you can create paths and ellipses and lines and all that good stuff. And you can, of course, draw text with scalable vector graphics and manipulate colors and gradients as well, and even manipulate the presentation layer of colors and gradients of a certain HTML5 control or like element, like a button. There are a few libraries you can use with SVG. So you can use JavaScript to work with your scalable vector graphics, and there are some JavaScript libraries that you can use to make them even more powerful and easy to understand that allow you to create full scenes programmatically, such as Raphael.js, and we'll go into that momentarily. Oh, and I mentioned you can use CSS with your SVGs, which allow you to use some standard stylings inline or in an external style sheet or something at the top of your page, so you don't have to manipulate it all. Excuse me, when just drawing your image. You can do it dynamically on the fly. One thing that's important to point out is there's a difference between how you render your graphical objects onto a screen. And the two different graphics types that we're looking at today employ two different models: retain mode and immediate mode. Now, this is something to think about because immediate mode that Canvas is doing, and Tara will talk about it a little bit more, allows us, she'll talk about Canvas a bit more, is you can think about it like drawing with crayons. You're just drawing something directly to the screen. It happens immediately. It's like kind of set it and forget it. It happens, there's no state around it. It's just being drawn out. Retain mode, it keeps a model of the objects that are rendered. So therefore, that's what allows us to work with it with JavaScript as well as style it with CSS. So you do have it in memory, and you can work with those objects that way. So it allows you to apply state and all that good stuff, and work with those objects and not just have them forgotten, have to re-render your whole screen every time you do something. So this is a quick dirty code of what defines SVG, Scalable Vector Graphics. Notice in this case we have height and width. We have to point it out to the namespace so that we can see how the SVG is defined here. We have a couple of rectangles. We're filling them with some colors, giving them X and Y so we can tell where to give them a height and a width and tell them where to start out there. But that's quickly how you can define SVGs. And I'm going to show you, I have one more slide and then I'll show you a demo in a bit. Some advantages of scalable vector graphics. One really obvious one is because it's scalable and it's using vectors. We have the ability to get at some really great resolution. So when you're trying to print the elements on your screen, when you have a high DPI, you don't see things pixelated because they allow us to work with different resolutions. And this is important, especially when you're using or viewing your site that's using SVGs on different form factors like a mobile device. I mentioned accessibility. SVG, since it's basically declarative XML, allows us to, it's actually part of the DOM. So when SEO or screen readers can easily understand and parse through that XML to understand the content of your page. Because it raises events, your user can interact with it. So there's click events, there's any kind of events that the user will interact with, including hopefully as we go through with SVG2 and above, is touch events and more interactivity as things have changed a lot since SVG was introduced in 2001. So the events is a big thing. So you can change colors, you can even do some animations, and see things like that. Declarative syntax, because it's XML and because it's been around for a while, there's great support in terms of tooling, and I'll show you some examples of that. So let me go to some quick demos. Oops, I got to actually go to those demos so you can actually see them. All right, hopefully you can see that. And on my screen currently is a site we showed you before earlier in the series. And this is just a bunch of demos that were written to show off some high-level view of HTML5 and its friends. And I'm not going to go through all the demos because I did them earlier in one of the sessions, but I'll point them out to you. The link is kind of a long link, but if you just go to bit.ly, I'll type it up here so you can see it. bit.ly H5 demos. This takes you to this page. bit.ly/H5 demos, and you can take a look at these SVG quick and easy demos. And of course, then right-click and choose to view the source. So I did that, and I opened some of them up in Visual Studio, and you can see here this is similar to the SVG definition that was on a slide, but in this case we're using paths instead of simple rectangles to draw that image that you just saw on the screen. So in this case we have a bunch of different paths. They have IDs, and they've got different fill colors, and so if I don't have this crazy brain where I can take a look at this and say, oh, I know exactly what that is displaying. So the tools are really helpful there. There's one called SVG Edit that you can create some simple SVGs and I'll export it as a path. Export it as an SVG as well. The way we have been able to use SVGs before as in earlier versions of browsers is just by having a .svg file and having our browser be able to understand that, just like we would with a GIF or a JPEG or something like that. But you can still do it that way, but the better power of SVG comes with incorporating it with HTML5 so you can actually style it and not just using it as a source for an image tag. So here's another example. It's very similar to what we were showing you before. We have a namespace referenced out, the width and the height, and 3 different rectangles. And this would show you the Italian flag if I ran that. A quick example of using CSS to style your SVGs. So here we can take a look at the body of our HTML, HTML in our body. And we have a div, which has a class called box. And we have an SVG here, which is creating a primitive of circle and giving a size and a radius. Excuse me. And then if we take a look at the CSS portion of our page, we're styling the box, giving it a width and a height and a background URL. And that backend URL is going out to this, same thing, this path. And then to our circle, which is, remember, our SVG element, we are applying some styling in terms of the stroke color and the fill color. So that's just a really quick example of using CSS. Even more powerful is the ability to use CSS and JavaScript. So scrolling down again, on top of different HTML elements. So here we have an input button. It says do something. Of course, there's no event handler to that yet. But we have a class, and it's called gradient. So if we take a look at my style section, I have my gradient class that is pretty empty. But we're using JavaScript here, and you can use JavaScript libraries like jQuery to. We're just writing it straight out into JavaScript here. But basically, on our load function, we're defining some colors. So creating an array of colors, yellow and red in this case. We're creating an SVG gradient. So create gradient with those colors that we just defined of the array. This line is pretty interesting, and it's basically encoding what we created to a data, so to the .svg type. And then for our CSS, we're manipulating that with our JavaScript. So we're taking that gradient class, and we're setting the background style to be a URL of this grad, which is now this .svg type. So that's it. So that is, in essence, doing something very similar to this by setting the background to this SVG URL, but with JavaScript and with some styling. So it's a very flexible graphics, I wouldn't say graphics engine, but it's a very flexible paradigm for working with graphical elements on your page. A couple things I wanted to show you as well is that IE test drive site that I mentioned. Tara's going to dive into this, but there's a bunch of different demos on here that use SVG and Canvas. If you click on more demos on the bottom, you see a couple more. SVG Gradient Maker. So this allows you to do your own radial or linear gradient and do an offset. Changing some colors around. Oh. So yeah, so you can mess around with some of this. It'll give you the markup and the SVG source if you wanted to play around with that. And there's a lot more. There are a lot more SVG tools around. SVG edit. So this is SVG edit. Allows us to, can do some text as I mentioned. And I would do this not for some really complex SVG stuff, but it's not liking me how I'm testing this out here, but all right. So you can, create a bunch of different things and then export it, do some layers. It's kind of like Paint++, just for SVG. You can see the menu here and choose to save the image, export as a PNG, but you want to save it as an SVG file and then use it on your site. But there are quite a few like that. Let me go back, make sure there wasn't something I was missing. So there's just some quick glance at what SVG is and some simple examples. In these slides, you can see that there are some generation tools, a couple that I pointed out to you. It's on the next slide. No. One is Adobe Illustrator. A lot of people use that to create graphics for their sites. Of course, you can save out and export to SVG. There's a great tool that one of the guys on the Mix team who run our Mix conference did called AI to Canvas. And I don't think Tara's going to show you AI to Canvas, but it is a neat tool where you can, it's extension to Adobe Illustrator, so you can export to Canvas as well. I mentioned this for Microsoft Visio. You can save out as SVG. And there are a lot of tools that allow you to actually just save out to that file type. Some libraries, these are great. Again, since SVG can work with JavaScript, you can use some libraries to denote your, excuse me, to create and work with these graphics. A really popular one is Raphael.js, but there's a few other ones listed here. And let me just show you that really quickly. So I just did a quick search on some use with the Raphael.js, and I found a pretty good introductory tutorial. And so you can go to raphaeljs.com and download that JavaScript library, and this will show you how to draw your first scene and just, declaring these different paper, rectangle, circle, setting it some properties, and being able to work with those different attributes that SVG has, such as the fill in this case. So we're filling the rectangle and the circle in this case. It talks a bit more about paths. So it's just putting some more shape around working with scalable vector graphics with this JavaScript library. So take a look at that, and shows you how to work with some events, which I thought is a pretty neat tutorial. So just do a search for Raphael.js and some tutorials around that, and you'll stumble upon this one. And I'll put it as a resource link on my blog. So back to slides, sorry. Taking me a second. There we go. There are differences between SVG and HTML5 Canvas, and we will talk about those after we discuss Canvas a little bit. But typically, you want to think about the strengths of either one. Again, with scalable vector graphics, it's good for getting at some high-resolution graphics, as well as being able to manipulate it with CSS and JavaScript because it's natively part of the document object model, and easily used with screen readers and SEO because it's XML-based. Now, when you're creating games, which is what we're going to talk about in the next part of the series, you can use SVG or Canvas or both. So we'll talk a little bit about that in a bit. So with that, I'm going to hand it over to Tara, and she's going to talk a bit more about HTML5 Canvas, and then we'll do a discussion about which one to use and when. So Tara,
Hi.
You there?
Yeah, I am. Thanks, Lindsay. Okay, so we learned about all the goodness there is with SVG, and again, it's been a staple and it's been around quite a bit. But let's really look at now the HTML5 Canvas object, which is really becoming a prominent graphic element as a part of the new HTML5 spec. Now, first of all, the Canvas element allows for dynamic and scriptable rendering of 2D shapes and bitmap images. It's great for really getting your 2D images on the screen with really good performance. This is not really new per se. Canvas was actually initially introduced by Apple for use inside of their WebKit component in 2004. And from then, it was introduced in a few browsers, Opera being one in 2006, and then 2006 it was released as a spec, and now is a part of HTML5. And you'll see this Canvas object really evolve in HTML5, and its API is now a part of the low-level drawing API that you'll see that comes out of the HTML5 spec around Canvas. Immediate mode, and I know that Lindsay went over retained versus immediate mode. Canvas works in immediate mode, which allows it for, again, to have very fast performance. So again, in looking at Canvas, again, a part of the new HTML5 spec, but it's really not a new element, but enhanced greatly in HTML5. So let's look quickly at the HTML5 Canvas. I'm sorry, we have a little bit of typo, but bear with me. So the first thing you do is declare the HTML5 element of Canvas, and you see it there on the right-hand side, Canvas, and I have just some text there. Now that text is really for a fallback. Let me explain that. So when you create objects as a part of the canvas, it really, when you denote a canvas, is consisted of a drawable region that's actually defined in HTML5 code in JavaScript. So again, it's a low-level procedural model. It's going to update this bitmap automatically or dynamically, and it does not have any built-in scene graph or DOM, so no document object model really, which is really something that you should realize is a definite difference between leveraging SVG. So to build anything in Canvas, you're going to really leverage JavaScript heavily and access this area denoted by the canvas to use this API, its full set of drawing functions, these common to the APIs, to dynamically generate graphics. Now, the great thing about the 2D graphics is some basic things that you guys are familiar with if you've been doing any JavaScript code or HTML, period. So it's rectangles, it's paths, it's lines, fills, etc. But again, there's no DOM there. There's no scene graph at all. You're doing this and executing this immediately, and once it's executed, if you look at the source, it doesn't know how it got there. It doesn't know how it's referenced. It knows that it has rendered it, and it's a part of your view. So it makes for great performance. But again, anything you do with the canvas, you're going to have to dynamically control in JavaScript. And once you've rendered it in the screen, there's no way to go back and access that afterwards. So just be mindful of what's Canvas' purpose. Again, high performance, but again, that is somewhat of a trade-off. All right. So when we look at Canvas at its base state, there are some key elements that comes with the context, the 2D context of the HTML5 canvas. So let's go over some of these somewhat briefly, but I want to make sure you kind of know which each one is for, its purpose, and how you would use it. The first thing let's look at as the state. So the 2D context represents the flat surface, right, whose origin is 0, 0, top left corner. And you coordinate the space values of x and y, x going right, y going down. To denote each one of the drawing state, it consists of certain things. So this state consists of the current transformation matrix, the current clipping region, and some current values of the following types of attributes. So stroke style, fill style, the global alpha, line width, line cap, line join, and the miter limit. There's a few others. Obviously, we're going to get into some of the few others, but basically the state is the current values of some of those attributes, the clipping region, and this transformation matrix, so where you're going to really do your great drawing or your dynamic generation. When you look at compositing, all drawing operations that you're going to do on your canvas are affected by the global compositing attributes. There are two of them. There's the global alpha and the global composite operation. The global alpha attribute just gives the alpha value that's going to be applied to the shapes and the images before they're composited onto the canvas. Now, when you look at the global composite operation attribute, it's going to set how the shapes and images are drawn onto the existing canvas or bitmap once they have the global alpha. So the global alpha, it says, hey, this is how I want you to apply this alpha value to the shapes and images before it gets composited onto the canvas. The global composite operation says, this is how I want you to set the shapes that are drawn into this canvas or this existing bitmap once they have the global alpha set and once the transformation matrix is applied. So a little bit of difference there, but that's how you do compositing. Colors.
Sorry, Tara, just to interrupt a little bit. This is a really powerful thing. So you can, do a couple of different drawing operations on the same, element. So one image, you could have an alpha channel, make it somewhat transparent, and at the same time, you can, do something else with it. So if it was a video, you can draw a video onto the canvas and make it, flip it around, put a gradient on it, and make it, so it's a really great way to manipulate your visual elements. Sorry, I think it's really cool.
No, absolutely. So this is one of the powers of leveraging the canvas to do those dynamic types of things. So let's go through colors and lines. So colors and lines, you have two main attributes there. There's the stroke style, and that's going to represent the color or the style they use for the lines around the shapes. And then you have the fill style, and that's the attribute that represents obviously the color to use inside the shape. So if we're creating a rectangle, for example, I could want the rectangle's lines to be of the color blue. And inside the rectangle, I could want the fill color to be yellow. So again, colors and styles, just basic attributes, stroke style and fill style. Now let's look at line styles. Line styles has a couple of different attributes. It has the line width, which obviously gives the width of the lines and to coordinate the space units. The line cap, it truly defines what your endings will look like on the ends of the lines. A line joins defines, okay, what type of corners do I want where the two lines join or meet. And the miter length. First of all, the miter length is the distance from the point where the join occurs to the intersection of the line edges on the outside of the join. And so that ratio is the maximum allowed ratio of miter length to the half of the line width. It's kind of interesting there from a drawing perspective. But just know it can be explicitly set using this attribute. So for those of you who are much more graphically inclined than I, this is a great thing to use to really give definition and creativity to your lines and your line styles. Shadows. All drawing operations are affected by four main global shadow attributes. So there's the shadow color, and obviously it sets the color of the shadow. There's a shadow offset, and there's an X and Y attribute for that. It specifies the distance, obviously, where the shadow would be offset in position of X and Y, or horizontal, positive, vertical distance, respectively. And then there's the shadow blur, and it's, again, how much of the blurring effect you want to specify, the level of the blurring effect you want to specify, which are shadows on your objects. Simple shapes. So I mentioned earlier about a rectangle. So a simple shape would be something very simple as a rectangle. And there are some methods that immediately draw rectangles onto your canvas and your bitmap. They are clear rect, and obviously that clears the pixels in the specified rectangle. It has four attributes, X, Y, and width and height. You have the fill rectangle, or fill rect, same four elements, X, Y, width, and height. And you paint the specified rectangular area using this along with the fill style. So, again, you determine how you want to paint this with the fill style set. The stroke rect, so it's obviously very much related to the stroke style we talked about. This method must, again, using X, Y, width, and height, it's going to stroke the specified rectangle's path using that stroke style, using the line width we discussed earlier, and the line join. And if appropriate, if you want, you can also set the miter limits. Complex shapes. The context always has a current path. So we're talking about 2D contexts here in relationship to the HTML canvas. There is really only one current path of the context, and it's not a part of the drawing state. So a path is, a list of zero or more subpaths. You still have one main path, and each subpath consists of a list of one or more points, and they can be connected through curved or straight lines, and there's a flag indicating whether the subpaths are closed or not. So if you really want to get into drawing something a little bit more complex than just the base rectangles and other things and get very creative, you would definitely use a path. And Lindsay showed you an example of a path in SVG, but very similar to what you would do here in the canvas. You would denote whether or not the subpath is closed or not, completed, etc. And then so you can make really complex shapes onto your canvas. And this is all, again, dynamic. Focus management. This is somewhat a part of complex shapes in that context. So you have some elements there of a draw system focus ring. So if a given element is on focus, it draws the focus of a ring around that current path of that complex shape. And you can say, follow certain conventions for this focus. It should draw this and how the context should be focused. Draw custom focus ring. So if a given element is already focused, and you want to configure your system to draw a ring in a particular manner, like you want a high contrast focus ring, you want it to blink bright yellow or something, again, much more creative than I, you can do that. Once you draw the focus ring, it gives you a Boolean of true or false on whether or not it is focused or not focused, and et cetera. So you can use the focus management around that. Lindsay,
yeah,
what were you going to ask? I'm sorry.
Sorry, I was just going to add, this is really useful with something to do with like screen readers and accessibility. So depending on if an element has focus, then maybe the screen reader zooms in on that, and they can read it a bit more clearly if there's text on your page or something like that. So this just allows us to understand what our user is doing on the page.
Thanks. All right, so let's move on to text. Again, basic text, but you have a couple of methods and properties that you can manipulate in doing text. The obvious one is font, so you can determine the font that you want your text to be drawn on. There's also a text align, a text baseline, still text, and stroke text. So again, this is not anything that you probably are unfamiliar with. Everyone uses fonts, but you can align your text obviously left or right. You can determine where the baseline of the text should be, the colors you want to fill your text, the stroke you want to outline your text. There's also a text metrics object that once you get the context of the text, you can call this metrics object and it will return it, and you can get the metrics of the text and the width. So again, a little bit more usage as far as really customizing your text on your page and your canvas. Images, if you want to draw images onto the canvas, obviously you can use the draw image method. And this method can be invoked by using a couple of different sets of arguments. You can do image and X and Y. You can do image with an X and Y, width and height. Or you can do an image and do a combination of X and Y and width and height. So again, you can really get creative of how you draw your image, specifically where you draw your image, or multiple images. Any of those that I noticed as far as the first element that's needed in that method can take the types of images of the HTML image element or HTML canvas element or an HTML video element for an image argument. So you have a lot of flexibility there. It's not just a static image that you can manipulate with the draw image method. You can actually take another canvas and place it on this canvas with this draw image method and manipulate it that way, as well as using a video. So note this is a very powerful. Images are not just the static images that you would typically think of as images. You can do another canvas element that has a multitude of other things on it, or a video. And finally, we have pixel manipulation. You can directly manipulate the pixel data in a canvas at the byte level using the image data object. So obviously think about how powerful that I can move pixels of each one of the images into getting the image data object to make really different type of graphical images or movies or type of graphical effects that I'm looking for. So again, for those of you who are much more graphically inclined than I, you can really get detailed on how you want each byte to respond and move and create different views of the images. And so those are just some basic things around the canvas objects. Again, very simple API there, but a lot of power in relationship to it. Now, all of the summary that I just gave you, and I know this is an eye chart, but all of the summary I just gave you on the state, the compositing, et cetera, these are the methods here that are involved in doing all of that. So I just gave you a generic summary of them, but here are all of the attributes and methods that you have to use for each one of the different components I just noted in your canvas using the 2D context. All right, let's move on because that could be a little bit hard to read there. So Canvas 101, as I noted, you denote your canvas element, and you kind of have a fallback here if you look at this. So if Canvas is not supported for the browser, what it will denote is, hey, no Canvas support. If it is, what it then will do is use some JavaScript here, get element by ID, and you notice my canvas, the ID is noted or named as my canvas. And then I can start to draw things once I have that element in my JavaScript by using the various methods within. So I get the 2D context, and then all of those great APIs I just noted, now I can leverage them and use them. And you see here I use the fill style and fill rect to draw a rectangle. And you see that on the corner a red rectangle is drawn. So let's talk about, really quickly before I get into demos, some of the power and the reason and the advantages of using HTML5 Canvas. And the main benefits are, again, you're using JavaScript to render this image. It's much smaller than you would do with maybe downloading a file or waiting for things to render because it has to remain resident or in a retained mode. It allows for some cool extras, right, like scaling and rotation and, like I noted, the pixel-by-pixel image access. So this could be very powerful. Being that it's an API, it is completely programmable. So you can build applications and games purely on the fly on the Canvas API. So this is truly very much dynamic. It's potentially powerful that you can even write an image editing suite that runs in the browser. So if you want to do that, you wouldn't have to use Photoshop required, again, because this could use literally the pixels to manipulate on the browser, in the browser. And it doesn't require any browser plugins. So there's no need for any control-based plugins to render graphics dynamically like, let's say, a Flash. So again, the performance is great. You're not downloading anything. You can really manipulate at the pixel level. You have the programmatic generation of images and videos, and you can build applications and games dynamically on the fly and therefore also change them on the fly. So there's a lot of power in using the Canvas, HTML Canvas and its API. So let's get into some demos here. So let me share out my Visual Studio. All right, so hopefully you guys can see that. So as you know, just like the Canvas 101 slide that you saw, something really simple there. I am saying, hey, here is my head, my title. All I have here is I'm going to use a script called mycanvas.js. And as an element, all I have in this entire thing is an ID of my canvas, the width and height where I want it to render, and the background of being black. Now let's look at the mycanvas.js. All right, if you look at the mycanvas.js here, very, very simple here. You see that I'm really now building everything that I want on my canvas. And I start just like you saw the Canvas 101 would start. On the load, I am going to get that my canvas, the element by the ID. Again, it was named my canvas. I'm going to get the canvas's context, obviously 2D here. And the first thing I'm going to do is build a rectangle. That fill style is going to be blue. And I determine the X and Y as well as the width and the height of that rectangle. Then if you go down here, you notice I'm going to do a path and draw an arc. So I'm going to determine the fill style. I want it to be red. The stroke style, I want it to be yellow. And then I draw an arc using that method. And I, use the radius of 50 to draw it. Use the math of pi to make sure I'm using the right mathematical attributes to draw the arc correctly. And then I do a stroke. We're done with that one. Then I'm going to say, hey, let's do a triangle here on the corner. And let's do a path to do this. So I'm going to start with the beginner path. I'm going to give it some attributes to move to, the line to, the stroke style, the width, all of the functions and methods that I just talked about, the attributes that I just talked about and available for Canvas. So let's build this and see what happens. Okay. So you should see on the screen right now that pretty much I just built, just as I noted, here's a blue rectangle that I drew on the screen. Here's my arc as a yellow. You noted that I said fill style of red, but nothing got filled. My fill was commented out, so that's a point to note. And then if you notice on the corner, I started a path and drew a rectangle. I wanted the stroke style to be white, and you noticed. And then I had the fill to be green. So you know that was there and it's green. So again, very powerful there. Let's close that down. Let's go back to a little slow in rendering. So let's change a few things here and see what happens. So again, remember, as I noted, again, it's very powerful because I could change things on the fly. So
Tara, sorry, Tara, we can't see your screen. Oh, there we go. Okay, go ahead. Sorry.
Okay, no worries. Okay, so I'm going to uncomment this out. So what if I wanted to start the path of starting to animate a rectangle? And this rectangle, I wanted to start with it going blue and going to green, right? So if I would compile and run this right now, can you guys see my screen, Lindsay? It did a black thing for me.
Yes.
Yeah, we can see it.
Okay, good, great. Okay, so you notice the rectangle is green now. But is the rectangle truly green? Not really. I've covered the blue rectangle here with the green one. So if I wanted to animate this, let's change a few things here just to show the process of starting to animate. Let's say I moved my rectangle that I started to create over just a little bit. Again, and what I could do here is start to add more and more code where I transition from blue to green. But I'll just show you here. If I build this again, you'll see that actually it's two rectangles starting to be built. And what I could do there is slowly fade out the blue, moving its, notice I just moved this 20, my X and Y over 20 to show the green. Instead of doing that, I could actually dynamically build the blue to move over and the green to move over as appropriate to dynamically show or pretend, if you will, as if it was going from blue to green. So again, very powerful, dynamic, you execute it in that way. Let me close this down. One last thing, I'll uncomment this, and I'll just run it again so you guys can see. You'll note that, again, I denoted I wanted the fill style to be red, but I did not call the fill method. So it never knew, even though I said, hey, this is a fill style, to actually fill that arc with red. But I wanted you to note that once I uncommented out fill, you see that now fill is red. So again, if you look at the source of this, all you would see if someone would view source, again, nothing is retained. All you see is, yes, I have a canvas, just as I noted in my HTML page that I showed you originally. But everything that I'm building on there is dynamic. It's not retained. It's immediate. The HTML page does not care how it got there, nor does it know. It just is rendering in this immediately. And so there's no DOM, very powerful as far as performance. All right. All right, so let's go back. Well, I'll show you one more thing before I go back, because pretty much the next PowerPoint I'll just show you, I'm going to get into Evangelist and just show you an example of this great, powerful library here that we can also use to do a few things. So, as it's thinking. All right. So what I showed you here, that, again, I have a canvas. If canvas is not available, I can have a fallback. Now, the best practice I want to say before I get into Easel.js so you guys will understand this is, hey, make sure if your canvas isn't available, other than just say, hey, your browser doesn't support canvas, too bad for you, go ahead and put some base HTML code in there that says if your canvas isn't available, this is what I'm going to show. Other than what you saw on my HTML5 page was, hey, there's no canvas available, too bad for you. The best practice here is detect whether or not the canvas will be available by creating an element, trying to get the context. If it does return true and it's good, you can then go ahead and execute your JavaScript to dynamically build your canvas. If it is not, then you can put the fallback and the non-canvas elements there. So just want to note, as you're using Canvas and the great power that it is, all browsers at this point may or may not support it, so make sure you have your fallback there by, again, denoting up front whether or not this browser will have the canvas available to it. All right, so Easel.js, let's go back to desktop here. All right. So that was using a canvas. Let's go over to Easel.js. So I'm going to go ahead and make this my start page. So you'll see here in my Easel.js demo, and this is a great type library. If you're ever curious about it, go to easeljs.com. We're going to use this really heavily when we get into our next section around gaming because it has a lot of power if you want to animate and truly make things dynamic in your game leveraging a canvas. So just look really quickly on my script here. The first thing I'm doing is actually referencing the Easel.js library. So let me go out and show you here. If you notice, I have a folder library, and I have the Easel.js library here. And again, go to easeljs.com if you want different documentation and examples of this. So this is a lot. Obviously, if you can read that, you're better than I. But including this will give you a lot of functionality to be able to dynamically do various things. So what I'm going to do here is, I've referred to my Easel.js library, I'm just going to denote things. One is a canvas, a stage, a text, image, and a logo. So in my init function, and again, this is again in my page, I'm going to do what you guys have seen has been familiar, is I'm going to get element by ID and canvas. I'm going to set a new stage, passing in this canvas element. And then I'm going to start to do some text. So I'm going to do a new text. This is what I want my text to say. This is the font I want to use and the size. This is the color. This is the X and Y I want with my text. I'm going to create a new image. And I said, new image, set it as my IMG type. This is the source of my image. So again, I have an image source there. I'm going to set on loaded my image. So it actually renders it into the canvas. And you'll see the set IMG is actually a function I created that looks for an event. So it takes in the onload, or it sets it so that when it loads, this is when it's going to set this image. And you notice I've added a listener. So this is a great example of leveraging Easel.js to denote what I call event handlers, so listeners. And then again, I have a tick here, so where I'm going to move the logo and animate that logo here based upon using the tick and moving the X coordinate. And then I'm going to update the stage. So let's see what happens when I do all this leveraging Easel.js. So compile really quickly. So there is my hello world. As you see, it's of type Arial. It's exactly what I put in there. Nothing more, nothing less. It's at size of 36, as I noted, and it's painted on the screen. Now you'll see my graphic, and it says awesome, and I said keep going over. Notice I didn't use clipping here, so I should use clipping so that it does not go off the page. But again, my hello world, it starts my image that's in my image folder, and then it moves it based upon going over 2, setting the X to -2, so it'll go over to the left each time. And I update this to call update on the stage, and you notice it moves. So very simple. Using Easel.js makes a lot of this possible and makes things very powerful and very simple, as you can see, dynamically. I'm going to run this again so we can look at the source. Okay, so you see it there. And if I look at view source, it's exactly as you see. Obviously I'm including the Easel.js, and then all that's there for the canvas is just the canvas. All of the functionality happens in this JavaScript. Now you could take this JavaScript out that I have here and just denote it as being in a separate library of my canvas, just like I did with the other canvas example. And so that if I did that, the only thing you would see in this source is the reference to the 2 script libraries and this one canvas element. So very simple, very powerful there.
And just want to add, we're going to dive into Easel.js a bit deeper in our next session as we talk about gaming and talk about the game loop and using, in this case, like Tara's using the ticks to make the animation move. So we'll talk more deeply about those, the development paradigm and the game loop in our next session. But it is great stuff.
Absolutely, absolutely. So if you want to know more about Easel.js, you see the link here. It's some great examples on the site of, and it would be a great prep if you're going to come to our next session on gaming, on some great examples of using the power of Easel.js to make or create a game. And again, we'll go over that in detail in the next section. So let's start to talk about SVG versus Canvas. So I'll let Lindsay first talk about SVG versus Canvas, and I'll do the opposite. Lindsay?
Great. Thanks, Tara. I mean, we've talked about this throughout. We've pointed out some things, so you've probably been able to pick out some of the differences between SVG and Canvas and where you'd want to use one versus the other. But this is just these are some high-level differences. SVG is shape-based, again, because it's scalable, so you can see your graphics on different resolutions, so that helps us when we're rendering on different devices with different screen sizes. Whereas Canvas is pixel-based. As you've seen with Tara's examples, you denote the width and the height of the canvas and then draw to that area on that context. The canvas is a single HTML element. As when Tara showed you the source of her different demos, you just see the canvas tags defined. However, because SVG is XML based, you have multiple elements like paths and shapes, and they become part of the DOM, so you can program against those different elements in the DOM and style them with CSS and interact them with JavaScript. You've seen examples with both of using JavaScript to manipulate the canvas and draw onto the canvas. With SVG, we used JavaScript briefly to draw onto our canvas, and we can also style with CSS, which you can't do with Canvas. For events, the user interaction is granular, and you can see that with the demo that Tara just did on Canvas, where she was moving her image over 2 pixels to the left on each tick. So she was manipulating the X coordinate of that element. Whereas with SVG, the user interaction is abstracted, so you can use the mouse events or any other type of events to get at that. Performance. So performance, as you can probably guess with Canvas, as Tara was talking about, with the immediate mode, performance is better because there's a smaller surface from whatever you're defining your canvas, however you're defining your canvas. There could be a larger number of objects, but because there's no state to them, they're just being rendered immediately, and so performance is higher. With scalable vector graphics, the smaller number of objects has better performance because of the scalability with that. So there's just a couple of considerations you need to take. Both are very powerful. Both have their great use cases, and you can use both in creating games and other HTML5 enabled sites. So with that, we'll talk about a few different scenarios where you would use Canvas and SVG, Canvas or SVG, and going along this, I don't want to say timeline, what am I saying, spectrum of where Canvas or SVG applies. So Tara, go ahead.
All right, thanks. So Lindsay talked about the differences of Canvas and SVG. Just note that there are a lot of things that you could do with scenarios where Canvas is a little better than SVG and SVG is a little bit better than Canvas. And she mentions them very much in a general space. But let's look at some of them as we build this slide. So with screen capture or video manipulation, Canvas typically is better just simply because, again, the immediate mode. But when you talk about lots of static images, logos, and diagrams, SVG is better. Also with high-fidelity documents for viewing or printing. Lots of scenes, lots of objects, Canvas wins there. Web advertising, but you notice as we start to go over, they really become almost equal when you look at interactive charts or graphics or 2D gaming. So which one do I pick? Which one is the best? Each technology has its own uses, and it's not like you abandon Canvas in favor of SVG or vice versa. You should use the ones that's appropriate for what you're doing. So, for instance, best cases for Canvas, things like interactive image editing, like cropping, resizing, that type of thing, generating faster graphics, image analysis, rendering game graphics like sprites and backgrounds. Now, you should think more about SVG if you're looking for resolution-independent web application user interfaces, highly interactive animated user interfaces, data charts, plots, vector imaging editing. In short, the best scenario you should do is use the best technology for the best usage. Use both. In a game, you might want to render faster graphics dynamically using Canvas, but then you might want to animate them using SVG. So in an image editor, you might want to render both vector and the raster graphics. So use both. And let me give you a quick example of something that's great in using both. So really quickly, let me bring up.
Just to, as Tara's bringing that up, I'm not going to show you because we're pretty much close to out of time. The resources slide, which is the last slide, if you print to PDF, links out to the sites that we were talking about, as well as some examples. And take a look at those examples and those different resources for learning more about different graphics. And we'll discuss more about Easel.js and the use of both of these SVG and Canvas in game creation in our next session. But Tara's going to show you one more example of where we've used both. And this is on ietestdrive.com.
Okay. So the first one I'm going to show you, you see my browser coming up here now, on the IE Test Drive is called the Blizzard. So I'm going to start to see the snowbank is actually SVG. The snowman is actually Canvas. I'm dynamically using some graphics here to create the snowflakes. You can't hear it in the background, but I actually have audio. Let me see if I turn it up there. The audio tag is being used here. So again, if you look at this, turn that audio off. Look at if you look at this using the F12 tools, you can actually really truly see where the Canvas is used, where SVG is used, and the like. So if you didn't go to our other webcast before, we talked about this F12 IE tools, very powerful. You can see here the divs as associated, the SVG, the resources, the script, and everything. And you notice the snowman and the snowstorm is Canvas, and it talks about performance. The snowbank is SVG, etc. So again, you don't have to use one versus the other. You actually can use both. Let's look at another one here. Let's look at the Let It Snow. Very similar. So you see here that I'm generating snowflakes again, have the window size, but here again I can rub my mouse back and forth and say season greetings, giving that the holiday. Again, and this is using both, the Canvas and SVG. And again, using some hardware acceleration that Lindsay talked about to dynamically do this. And if you're interested in looking at the code, the source, and how they did this, definitely go to iemicrosoft.com/testdrive, and you can see a lot of these great examples. The last thing I'll show you, because we're out of time, is there is a great MSDN article here that discusses graphics in HTML. So going over some of the things we discussed today, the SVG, the high-level overview of SVG and vector graphic scenarios. It goes over the HTML5 graphic technologies using Canvas. It goes into detail of when to use Canvas and when to use SVG. And so this is a great introduction and going into some details here on the MSDN library on some of the things we talked about, so you can know when to use both or how to use both in a browser-type scenario. All right.
And with that, we'll hand it over to Tracy. Thank you so much for attending today. We have another one more part of our series on Thursday at the same time, going into using these and actually creating games. So thank you, everyone, for attending. And Tracy, there you go.
Great. Thanks, Lindsay. So we have a survey up for everybody on the screen now. All you need to do is follow the links provided to complete the evaluation. Also, the recording for today's session is going to be up on Microsoft.com/webcast. It usually takes about 48 hours to have that posted up there. I do want to extend a very special thank you to both Lindsay and Tara for presenting today. Ladies and gentlemen, you may all disconnect from the audio portion of today's presentation.